All right, moving on to three-dimensional shapes. Okay, we did two-dimensional area and circumference and all that. Now we're going to look at prisms, cylinders, pyramids, cones. Okay, even getting into spheres. But what we're going to focus on in this lesson are the prisms, cylinders, pyramids, cones, and their cross sections. Now, right now, you may not know what a cross section is, but it's pretty simple. We'll kind of talk about it here. First thing we're going to do is just a little exercise in drawing three-dimensional shapes. So you're going to it might take some practice for you, but first thing we're going to do is sketch a right rectangular prism. To do that, here's the best way to do it. I'm just going to make my pen a little thinner here. Draw a rectangle, because the base is a rectangle. Okay. Then draw another rectangle, kind of, but not exactly behind it, but like offset a little bit. So draw like another same exact rectangle. Oh, I know I said same exact rectangle and mines are different, but all right, whatever. So, and then what you do is you just connect the corners. Go like that. Okay, go like that. Go like that. And then back here, this one is kind of hidden. You can't see it, so just kind of do it dotted. See that? So now there, and actually this one's hidden too. This one should have been dotted. See that? If you dot that one, it's kind of like, whoop, I don't want to mess up. So there, and then dot that. You can see that. Anything you can't see is kind of dotted. All right. So there is the rectangular box, rectangular prism. Right circular cylinder. So for a cylinder, we're going to do like this, and then draw a kind of like a circle, but just because you can draw a circle at the bottom. Or I like to do this and then just kind of do a dotted at the back end, and then same thing, and then dotted on the back end. Okay. Or you could even put it solid on the back there, because looking at it from the top, you would actually see the whole thing, the whole circle. All right, so there's a cylinder. A square pyramid. A square pyramid it'll have a square base. So you're going to draw a square. And then pyramids come to a point. So we're just going to put a point somewhere up here. And then just go down and connect to each corner. And then all you could do dot it in the back there. Once you get behind, you could just do it dotted. And then oh no, that one you would see, my bad. So the way I drew it, you would see that. Okay. There we go, because there's the back one right there. Ugh. Okay. There we go. Oh, whatever. So there's your square base, and then it's a pyramid because it comes with the top at a point, and then a right circular cone. For a cone, I would just draw a circle, okay, and then a point at the top, and then come down and hit the sides of the cone there, and that's pretty much good enough for a cone. If you want to do that dotted because it's in the back, you can do that, and there's a cone. It's pretty much all you would see, right, for a cone. All right, so you'll get practice with that, but there is how you draw three-dimensional figures. Okay, so what's a cross-section? A cross-section is when you slice through a three-dimensional figure. You could slice parallel to the bottom, or you could slice across, or you could slice down or diagonal. Think like Fruit Ninja, right? You ever play Fruit Ninja and the watermelon comes up and you're like, and you slice the watermelon in half and boom. Or you could just think of slicing a watermelon, right? When you have a watermelon, you slice it. What does it look like? What does it look like when you look at the inside of a watermelon and you slice it? Or an orange, right? You cut an orange in half, or anything you cut in half, and then take a look at it. Okay, what you're looking at is the cross section. All right. So, and it's a plane. Sometimes they call it a plane because it is a plane, right? A plane is just like a flat surface. This is a plane. So what you're seeing is flat. Anything that's flat is a plane. So what you see when you slice through a three-dimensional figure, that is the cross-section. So you can see it drawn here. Here's figure 1. There's a cross-section shaded. It's in green on here. Here's another cross-section. It's kind of going diagonal. It's not parallel. So in figure 1, they drew it kind of parallel to the base. In figure 2, they kind of drew a diagonal, not parallel to the base. But see how they're both still rectangles? All right, and then in figure 3, there's kind of a weird shaped cylinder going on there with, but it's not a right circular cylinder. It's just some other weird shaped cylinder because it's got curves to it. They call it an oblique cylinder. But see, you could still do a cross section. See slices. See the slice down the middle is shaded. Okay, you just put a plane right through the middle, a knife right through the middle, slice. That's a cross section. Same thing for this one here. That's a triangular prism. A triangular prism. See how it's a triangle base, but it's three-dimensional. Okay, slice through. What do you get? You get a triangle. If the bases are triangles, the middle is going to be a triangle. It's pretty simple. All right. What they want you to do here are draw cross section. So here's three-dimensional figure. Draw cross section. Draw 2 cross sections. One is going to be from like slicing this way, and then one's going to be slicing this way. Okay, so slice this way and then slice that way. Slice this way and then slice that way. All right, slice this way, slice that way. All right, so there is all your slices, and let's see what they would look like if we actually did that. So obviously if you slice this way, you're going to get a circle. So you're just going to get that. That's what it's going to look like. All right. Think of I don't know. Think of anything that's cylindrical, and you slice through it. Take it up. Look at the middle. Right. It's going to be a circle. If you slice this way, it's kind of like slicing an orange, right? Well, not really an orange because an orange is in a cylinder, but I shouldn't say an orange. That's a bad example. That's a sphere. Okay, you have to slice something that's a cylinder right down the middle, right, and take a look at it. What you actually would see is you would see a rectangle. Cheese is a good example. Sometimes cheese comes in cylinders, blocks. I don't know if you've ever seen that. And you would just slice it right down the middle, take a look at it. It's going to be a rectangle. It's going to be a rectangle. It's flat on top, flat, right? And then it's flat on the sides. It's all you actually see. If you're just looking at that piece right there, it's going to be a rectangle. A hexagonal, pentagon. This is a pentagonal prism because it's a pentagon base. Well, if you slice it one way, you're going to see a pentagon. Okay, well, hopefully your pentagon looks better than mine. All right, if you slice it the other way, you're going to see a rectangle. Same reason as this here. This one, if you slice it one way, you're going to see that shape that's on top, whatever that is, an L shape. You're going to see an L-shaped figure. And then if you slice it down this way, for example, down that way, you're going to see a rectangle. And then here, if you slice it this way, you're going to see the shape of that, I don't know, what's that, like an in-ground pool or something? All right, whatever that shape is there. If you slice it this way, you're going to see a rectangle. When you slice a prism a certain way, you can always see a rectangle if you slice it a certain way. If you slice it this way, parallel to the base, you're going to see the base. If you slice it the other way, you're going to see a rectangle. Okay, so if you slice perpendicular to the base, you're going to see a rectangle. If you slice parallel to the base, you're going to see whatever the base is. All right. Example 1. Example 1, in the following triangular pyramid, a plane passes through the pyramid so that it's parallel to the base and results in the cross section. So see this cross section right here? I'm going to kind of highlight it. There's the cross section right there. Now, they kind of show it here, but it's tough to see. The whole height, they're saying, is 18. So the height of the original pyramid is 18. Okay? The height of your new pyramid, see this new pyramid that's created here? This new pyramid, this smaller pyramid that's created with the cross section. Okay, this pyramid right here, that's in blue now. The height of that one is 12. Okay, so this height here is 12. So what we can do is we can write a ratio of the height of the smaller pyramid to the bigger pyramid. And that ratio is 12 to 18. They're both in millimeters. And they give us the area of the triangle A prime, B prime, C prime. So they give us the area of this cross section right here. They give us this area. And that's 28. So I'll say equals 28 over, and I want to find the area of the base. I want to find this. Well, I'll call it A. Okay, that's this area right here. However, this proportion doesn't work because remember, area is in square units. We learned in our last lesson the scaling principle for area. You have to square the single dimension, say, so in this case it's height, in order to get the area. So we actually have to square this, and then we'll equal the areas. All right, so that's going to be 144. Oh, you know what I'll do? I'm sorry. I did this differently. This reduces to 2/3. Then I'll square it. That's easier. I was wondering what I had in my paper that was different. I forgot I reduced that. Yeah, you don't have to do that. You could just square it the way it is, 144 or whatever that is. But I just reduced it. 12 over 18 is 2/3. So this is going to be 4 over 9. 4 over 9 equals 28 over A. And then just like how we were doing the last lesson, 4A equals, and it ends up being 252. And then divide by 4. And that will give you the area of that base, and it comes out to be 63. And it's cubic millimeters. That's the units, cubic millimeters. 63 cubic millimeters. All right, example 2, a cone has a base area of 36 square centimeters. So we have a cone, and the area is 36. All right, so we have this cone. A parallel slice 5 centimeters from the vertex. So from the vertex, so from here, 5 centimeters down, there's a slice. So there's a cross section. A slice is a cross section. All right, and that's 5 centimeters from the vertex. All right, so basically I have a new cone. All right, so I'm just going to draw a new cone. Okay, and the height of that cone is 5. All right, I don't know this area. Okay, I don't know, question mark. I don't know the area. That's this cone I drew right here is the cone right here that's formed from the cross section. All right, and has an area of 25. So the parallel slice. They do give us that area. My bad. I'm sorry. This area is 25. All right. What they don't give us is the height of the original cone. So we're going to do a proportion like we did here. 5 is to x, we'll call it h, height of the cone. So the height of the slice to the height of the cone equals the area of the slice to the area of the cone, but that's only if you have to square the ratio of the sides, of the heights. So just kind of how we did here. So it's 25 over h squared equals 25 over 36. And then, of course, if I have 25 on top, I must have 36 on the bottom. H squared equals 36, and then take the square root. H equals 6. So the height of the cone must be 6 if that parallel slice was 25. All right, last one here. A general hexagonal pyramid. A hexagonal pyramid. Okay, a hexagonal pyramid has a height of 10. So a hexagonal pyramid. There's a hexagonal pyramid. Basically, what does that mean? A hexagon base, right? And it comes to a point, okay? The height is 10. And a slice 2 inches above the base. 2 inches above the base, okay, now 2 inches above the base is actually 8 from the top. Okay, so if I draw my new one, I'm going to draw my slice. Smaller, right? Okay. It's 2 inches from there, so that means it's 8. It's 8 from the top, guys. All right, 2 from the base is 8 from the vertex. So we always got to go from the vertex. A slice above the base area has a slice 2 inches above the base area has area 16. So this is 16 here. The area is 16. Find the area of the base. Okay, find this. All right, so we're going to do 8 is to 10 as squared, as 16 is to we don't know, A. All right, so that's going to be 64 over 100 equals 16 over A, and that's going to be 64A equals 1600, and then of course A is going to equal 25 square inches when it's all said and done. All right, I will see you tomorrow.